Prakash, working as an assistant professor in the Department of Mechanical Engineering, SNS College of Technology. Next, let us discuss what is the difference between the ideal cycle and the actual cycle. Okay, so in ideal cycle, the no leak heatage takes place because the process is adiabatic process. So the other name for adiabatic process is isentropic process. So in isentropic process, no heat is supplied or no heat is rejected. So because of this, there is no friction in the ideal cycle. But in real time, when the cycle is implemented, what happens is definitely there will be a heat leakage and there will be a friction because of the moving parts. As steam is moving inside the tubes, definitely there will be a friction. So, and reversibility also takes place. So, this is the common difference between the ideal cycle and the actual cycle. And now let us see how it is working. As we discussed, initially boiler is the first component. What is the purpose of boiler is water is converted into superheated steam. So, and then this enormous amount of heat energy in the steam is extracted as an work in the turbine. Okay, and then after that it goes to the condenser where the heat is rejected, and then the condenser is used as a pump to supply in the closed loop system. Okay, so here the process going under the isentropic process. Okay, so here the condensate, water, heat rejected, and everything is in isentropic process. So now let us have a small assessment. Okay, so in a steam power plant, where the maximum heat is supplied. Okay, so this question is taken based on the thermal power plant and Bharat Heavy Electricals Limited, Belt Trichy, because boilers is manufactured there. So maximum heat supplied is, what are the option given is turbine, condenser, boiler, pump. So you can have a guess what may be the answer. So the answer may be boiler. Okay. So here the heat is rejected in the Rankine cycle in the following process. Okay. So this is also some question which is related to the thermal power plant and the belt trichy. So again there are some assessment questions. So where will be the work output is given. This is based on the gate questions. Okay, where change in enthalpy related to gate, and when compared to the actual cycle, the efficiency of the ideal cycle gives more efficiency or less. So let us have a discussion on the previous lectures, and then you can give the statistic answers in your comments. Okay, when the video is posted, you can post your comments. So now in the design thinking stages, we are having empathy, define, ideate, and then the testing process is taking place by using these four processes. Here there are four processes. The first 1 to 2 is isentropic compression process. So here in the pump 1 to 2 isentropic compression takes place, whereas in the boiler constant pressure heat is added. Okay, and in the turbine isentropic expansion takes place, and then the condenser heat is rejected. Okay, these are the four major processes involved in Rankine cycle. And we can calculate the estimation, we can calculate the work done in the turbine, and then compressor with the help of enthalpy, where we are having 1 to 2, 2, 3, 3 to 4, like that we are having the points where this heat, based on this enthalpy, we can calculate the heat input and the efficiency. Finally, the efficiency is given by the work done by the turbine minus work done by the pump divided by the heat supplied. Okay, because the efficiency is output by input. And applications we are using in steam power plants, nuclear power plants, binary cycles, waste heat recovery boilers, MHD power plants. These are the applications. And then what is the advantages is, when we are using a Rankine cycle, definitely the turbine work is increased because only less amount of heat loss takes place, and the pumping power is decreased. These are the main advantages. And what is the most advantage is that it increases overall thermal efficiency. Okay, So the maximum heat which is utilized is converted into work done. So these are some assessment questions. So you can solve and you can give your answers in your comments. And now we are coming to the conclusion. Okay, we are going to summarize what is Rankine cycle, what we have discussed today. Okay, in the Rankine cycle we have seen what are the fundamentals and overview, and we have discussed about the what is the empathy part, and we have discussed what is an ideal Rankine cycle, that we have defined the ideal Rankine cycle, and we have compared what is the comparison of ideal cycle and the actual cycle, and we have seen how to calculate the efficiency, thermal efficiency based on the enthalpy and the work done, and we have discussed about the advantages, and we have discussed about the applications. Okay. So this is our some references which we can refer for this steam power cycles. That is our ideal Rankine cycle. Thank you.